Hello and welcome to meetup number 70 for beginners Python and machine learning. Tonight we'll be looking at how to extract data from Rss feeds and how to extract it from XML files and HTML web pages. We'll be using feedparser and beautiful soup to achieve this. So a couple of things we're going to try to do is get some exchange rates from the Reserve Bank from their RSS feed, and we're also going to look at the ACCC have got a web page on petrol price cycles, so we'll see if we can extract some information from there. So this session has I've created a notebook on Google Colab. So you can follow along, just take a copy of that. So I'll show you how to do that. The link will be below the YouTube video in the comments, and it's also on the meetup page where you can register for this event. For those who are not, it's a good idea to register for the Slack space. So you can send comments in through that, or you can send them just through the YouTube chat for me. I do half the sessions here. Arun Prakash does the other half, and he only looks at the Slack channel for comments. So you do need to be a member of that Slack space if you want to do more of the machine learning stuff. All right, let's get started. To use Google Colab, you just need a Google account. Click on the link, and that'll bring up my notebook. And then you'll want to save a copy of that into the drive, onto your Google Drive. So you can say save a copy in Drive. If you don't do that, you'll get a warning message. And I'll just show you what happens if you don't do that to start with. So today we're going to be using feedparser to read RSS feeds, and feedparser doesn't come by default with Google Colab, so you have to install it. So to install it, you run this command line command, which by putting an exclamation mark at the front of the line, it allows you to run the command line stuff, and press Shift Enter. And it says warning, it gives you warnings. You could try running anyway. But your best bet is to make a copy of this, save a copy to Drive. That will create a copy for you, and then you can make any changes you like in this copy. And that's the point of the exercise tonight, is for you to be typing stuff in and trying things out. Okay, so I select the cell again, I type Shift Enter, and now it will go away and install feedparser, which is a Python third-party library that will allow us to read RSS feeds. Now I've given you a link here for the documentation. If you hold down, for me it's Command on Mac, I'm not sure on Windows what that is. It becomes a hyperlink, you can click on that, and that will take you to the documentation page. So feedparser is great for quickly reading RSS feeds and XML. So what are we going to be looking at today? So I've got a close that one. I've got a link here to the Royal Reserve Bank, and they've got a web page where they've got what the current exchange rates are. So let's have a look at the exchange rates. That's what they are, but if we want them in a more computer-friendly format, we look at this RSS feed, and so we see here they kindly provide an RSS feed. So if I click on that, it produces the XML that is fed by this RSS. So RSS means it means several things. I looked up it used to mean really simple syndication when I remember, but it also means RDF summary, RSS site summary, RDF site summary, or it can also mean something site summary. So I wrote them down. So I've put them here. Really simple syndication, rich site summary or RDF site summary. And RDF, for people who want to know, is Resource Description Framework. And you can see RDF is used frequently through the XML file. So an XML file looks a bit like HTML. It's got these angle brackets, and I'll just make that a bit bigger so we can see it. It's got angle brackets with tag names. So here we got tag name of channel, title, and it's closed with the slash and the name. So the title here is Reserve Bank of Australia pipe exchange rates. You also see some of the tag names have got what's called a namespace in front of them. So the RDF colon says in the RDF namespace we're using this capital RDF, and then it gives a name for this namespace. And that's so that namespaces are really just about preventing two people trying to use the same tag name in the same XML file. So this RDF is owned by w3.org, and they've just given a URL because they know that's going to be unique for them, and no one else who doesn't have control of w3.org should use that name. And so they can just put RDF colon and know that no one else will have a name RDF colon RDF where little RDF is this namespace. So I'm going to keep describing this. If you've got any questions, please send them to the Learning to Code channel in Slack for Beginners Python, or on the YouTube chat. And if you like the video, click on the like down below. Okay, so feedparser will read the XML feed and will extract all this data and put it in a form that's easiest for us to use. So let's see how we do that. We've successfully installed feedparser 5.2.1, and now so we can use it, we're just going to import it into our Colab notebook. We'll also import Pretty Print, which is just a standard library for get pretty printing, and HTTP, which is a standard library for comparing HTTP status codes. That's purely optional. You don't really need that one, but I'll just show you how you can use it. So Shift Enter to import those things. So feedparser pretty much just has this one thing. Parse is the one command, and we just provide it with a URL as a string, and the results will go into P. Well, we just create a variable called P, and we'll put the results in there. And we can see whether that was successful. Any network time you're using networks, it's a good idea to check for success because lots of things can go wrong in networks and websites and RSS sites. So we parse the URL and we get back a status and a modified date. So let's have a look at those. So the status is 200, which if anyone knows their HTTP statuses, then 200 is success. And the data was last modified at 6:50 GMT on the 28th of July. So that's just under an hour ago. When you're using feedparser, often you'll be wanting to recheck the RSS feed and see if the data has changed since it was last modified, the one that you've got. So we've got 650. So we send in this extra tag, modified equals p.modified, and if the data has changed, we'll get a new set of data. If it hasn't, it'll just come back and say it hasn't changed. So I'm storing this in P2, and let's have a look at what we get with P2 if we run this. So this is optional, but you know, it's how you play nicely with network and server resources, and so people like you to do this so that you don't overload them unnecessarily. The feed has not changed since you last checked, so server sent no data. That's a feature. and we got 304, which HTTP status 304 means not modified. And here's where we can use the HTTP library we imported earlier, and we can use, it's got some HTTP statuses in there that we can compare against. So all we would do is compare p2.status with http.httpstatus.modified to see if that's what we got, and that will return true. So it's just a bit more readable than just saying comparing p2.status to 304. People don't know what 304 is off the top of their head, but by using these names from the HTTP library, it just makes it a little bit more readable. Now, feedparser has been designed so that it can use either RSS feeds or atom feeds. We're not going to be using atom feeds tonight, but atom feeds have two main sections. They have a feed section and an entries section. So the feed is like a header at the top, and then it has one feed and many entries for an atom page of data. RSS has a similar structure. It has a channel for the header and then many items. So that you can use your same program whether you're dealing with atom feeds or RSS feeds. You can call them either items or entries, and they'll be referring to these, or you could call them either feed or channel, and it'll be referring to these in both. So to get the list of RSS items, we can either use P as a list and use the key items. So P is a dictionary and a dictionary type object, so it'll give us, using the key items, we can get a list of those items, or we can use P entries, or even P dot entries. We can use that as a like an attribute of the class. We can't use P dot items because P is a dictionary, and P dot items returns key value pairs, as you would know what dictionaries do. So let's run this cell. This will tell us exactly what type P is, and then it'll loop through all the items in P, and it'll print what's in the link tag of that item. So you can see type P is of class feedparser.feedparserDict, and when I said is it an instance of dictionary, it says true. So feedparserDict must be a sub class of dictionary. So everything we can do with a dictionary we can do with feedparserDict, plus we can do extra things with it as well. It's given us this list of hyperlinks, so they've all come out of the link tag. So if we go back and look at the RSS, we can see there's the link tag here. So every item, there's the item, there's the start of an item. If I close that one, I'll see the start of the next one. And you can see, so there's several items in here, and each item has a link tag, and that link tag is what we've extracted, and it produces a hyperlink that you could even click on, and so if I clicked on Japan, it'll open a new page and it'll scroll to Japanese yen, so we can look at it straight there. So I hope you're following. If you have any questions, remember to ask me in the chat, and I'll see if I can answer them. So task 1, display the whole item for Japanese yen, and how does the original XML compare to the feedparsed dictionary? Okay, so we can look at here. Let's have a look at what P items is. So I can just type in this Python function, tell me the type of P items, press Shift Enter, and it tells me it's a list. So with a list, I can just use list indexing on it. So a very simple answer to task 1. I can see that it's the third one down here, and the list is 0 indexed in Python, so that's 0, 1, 2. So I'm really just looking at the index 2, and I press Shift Enter. And this gives me everything in items 2, and you can see if I find here the target currency is Japanese yen. So I found that's everything that's in item. So the question is, how is that different to what the original XML that came from the RSS feed? So let's have a look at the RSS feed. So here we've got an item. In the item we've got title, link, description, then we've got DC date, so they're using namespaces here, date, language, audience, statistics, type, and there's a bit of structure going here. So inside statistics you've got all of this, inside exchange rate, which is inside statistics, we've got things like type, value, unit, decimals, and they're all in observation as well. Yet when we look at this, it's all been flattened. It's all at the same level. The namespaces, rather than having CB colon, they've renamed that to CB underscore base currency, and it's all flattened. All the structure's been taken out. So it tells you statistics here is a parse type resource, but it doesn't say what was in the statistics or what was in the observation. So that's some of the differences. What else have we seen? Oh, so summary. Summary here, this Australian dollar Japanese yen representative rate. If we look at the original, Australian dollar Japanese yen representative rate is in the description field. So a couple of these field names they've changed just to bring it into line with the Atom and RSS compatibility, to make them both use the same values. So I've written down these. Oh yeah, so DC date has now become updated and updated parsed. So updated is giving us the date as a string, but obviously that's not a lot of use to us, so it's also parsed it into a date where we can get the year, the month, the day of the month, the hour, minute, second, weekday, year day, and is daylight saving. So I've provided a solution here for you. This is another way of doing it. We can go through the items and do a conditional to check if the target currency is Japanese yen, and if we get to that one, we can pretty print the item. So let's do that. How did I print this one? Oh, I've just used Google Colab to show me what the immediate value is of that one, and this one I'm going to print it. So I'll press Shift Enter, and that's showing me the same dictionary. It's just giving me a little bit more formatting, but there's the same answer. Very good. Okay, so say we wanted to read all those exchange rates into a dictionary, and then we've got a dictionary that's got them in there, and we can use it later in our program. We can just look up in the dictionary what the value of any exchange rate is. So for this, we'd loop through all the items, and we can try p.entries because that should be the same as p items. And first of all, we'll create an empty dictionary called exchange rate, and I'll say it's a dictionary. Okay, so then in that dictionary I want to say that I'll assign the value for item, and we want it to be by target currency is going to be the key in the dictionary, so we're going to look up target currency. So remember, that'll be things like JPY or USD for US dollars. And then the value is, we're going to get that out of item, and it's going to be CB value. All right, now we can look up that dictionary and see what the exchange rate for Japanese yen is. And it's 75.37 yen per Australian dollar. So that's task 2. So anyone have trouble doing task 2? Okay. Right, so I provided a solution here. This is a bit more comprehensive solution. So we're trying to read all the exchange rates into the dictionary. So that's really this line here. And what I've done, I've used dictionary comprehension, because this format is a pretty common format. You want to create your dictionary, you want to loop through all the items and create the dictionary that way. So there's our creation, we've got the key, we've got the value, and there's the loop. And we put those in curly braces, and that creates exchange rate. So that line there will do everything that those first 3 lines have done in my solution there. Then I grab all the keys, I sort them alphabetically, and then I look up every single one of the rates. So I've done it a bit more comprehensively. I'm doing all of them rather than just Japanese yen. And one of the things, let's have a look at what that looks like. One of the things I wanted to do was align on decimal points. Now, you know, in format strings you can right a line, or you can left a line, or you can center a line, a string, but you can't, there's no built-in function for aligning the decimal points. So I've created a little function myself called align point that's going to do it. And what I've done is take the value that's come from item, I've put it into a decimal class, and we'll see why I've done that later. Then I take the integer part of that and I align that to the right in 6 places, and then I print everything that's not the integer. So I subtract the integer from that, and I get 6 characters. That one's aligned left. So now if I use negative numbers, there aren't any in this list, but it does mess this up a bit. So I check first for negative, and if it is, I print out a minus sign and then do run align point. I call it self, so it's like a recursive call. Get rid of the first space because that's where the minus sign's going, and then but only change one of the spaces, only get rid of one of the spaces, and then do the rest as a aligning point on the positive value of that negative number. All right, so that seemed to work. I've got all the decimal points lined up, and the exchange rates, the exchange codes. So you might have noticed that these numbers that we were getting, let's have a look. If I scroll back up, the number, oh yes, so there I printed it. So what would happen in this case, if I didn't print, I just said, tell me what the value is of exchange rate. You'll see it's actually got quotes around it. So feedparser is using this as a string. And you think, well, that's a bit inconvenient because it's really a number. But in this case, it's actually being very helpful. It's a string because it preserves the number of significant figures in that number, and it makes it a lot easier to convert to a decimal. So when you're creating these decimals here, you're much better off using a string as the value that you're providing to put it in as a decimal. And we'll look at a couple of examples to see why that is. So if I did 13.4500, it knows that 00 there, even though they're zeros, they're significant zeros, so it doesn't lose them. So the decimal class will preserve that. And so let's print these numbers out. So it also prints out 13.4500. And it will save that. If I was adding two numbers together, it would make sure that it had the right number of significant figures for both. Now here's an example where I don't have it as a string. I'm providing it as a floating point number. So I thought, well, this should do the same, 1.1, put that into a decimal. But when I do that, it doesn't know how many of the figures are significant because it didn't come as a string. So it uses all that it can. And of course, decimal numbers can't be stored exactly in binary. And so because of rounding errors, we get all these places over the end, at the end here. So it's quite inconvenient. So using them as strings is quite a useful way of working with these numbers. And I've also tested the minus some negative numbers here to see how they work, and it puts the minus sign out the front. So quite happy with that. All right, so we've used feedparser now, and we just provided a URL as a string. But feedparser is quite flexible. We could have provided all the XML as a string, or we could have provided a file name and it would have opened it up off your local file system. Or it could have opened a file handle, and that could use an open file handle and read the values. So here's an example of providing an open file handle. And here we'll use the URL lib library, which is a standard library. You don't need to install it, but you do need to import it. It's a standard library for sending URL requests and getting the response back. So by providing that URL open for this URL as a string, we can store that in a page, and then that page becomes the response from that URL. So we can do this. We can say p3 equals feedparser.parse and parse the page, and the page is an open file handle. So what feedparser will do is it'll do page.read. The problem is you can only do page.read once. So if I had several things wanting to look at that same page, then the best thing for me would have been to use page content equals page.read, and then it will store all the contents, all the response from that XML URL, store it in the variable page content, and then I could pass page content around to the different things. However, normally this is fine. You would only use the URL open once, so once per request. So in this case, I've kept it the way you would normally use your code. So let's have a look at running this, check it works. What we're going to do, we're going to use feedparser with URL open, and then we're going to display all the currencies, and I've just used list comprehension here to put it all in one line. So it's going to go through all the entries in P3 and put them in, extract the target currency for each one, and then put them into this list and tell us what the page get code was. So this is the alternative way of getting the HTTP status code, because feedparser is not doing the request now, it's URL lib. So we can't get the status from feedparser. And I'll just click in here and press Shift Enter. And I have to click in here first to import, and then Shift Enter in this one. So it's gone off, it's grabbed the RSS feed, and there's all the exchange rates, currency codes that it's returned. Okay, so that's all really I'll do with feedparser at the moment. Feedparser is a simple way of quickly reading RSS. The fact that it's flattens the structure can make it easier to navigate through and get the data out. And RSS feeds are supposed to be simple anyway, so that's probably not a bad thing. But we can use these other libraries, Beautiful Soup, for example, to also parse the XML. So let's have a look at how it would work if we use Beautiful Soup. Now the documentation for Beautiful Soup is available at this URL, crummy.com, and I can never remember all the Beautiful Soup commands, so I often have that documentation open when I'm doing this web scraping or XML parsing using Beautiful Soup. Now Beautiful Soup, you can't just put in a string URL, so it's not as flexible as feedparser. You have to provide the response object here, page, from a URL open. So that's why I really demonstrated URL open before with feedparser. So we put the string of the URL into the URL open function, store that in page, and then pass page to Beautiful Soup. And then we have to tell it what it is we're trying to parse. Are we trying to parse HTML or are we trying to parse XML? So this is XML. You saw it's XML before. You can see it looks a bit different to HTML. Right, so when you're using Beautiful Soup, we stored it in a variable called soup, could be called anything, and then it uses soup.item, will find that first item tag in the soup, and then prettify just makes it a bit easier to view. So let's print that out. And we can see here that it's preserved all the structure. We've got statistics inside item, inside statistics we've got country, institutional abbreviation, and exchange rate. Inside exchange rate we've got observation. Inside observation we've got value, unit, decimals. So it preserves all the structure there, so when we're navigating it we have to also follow the structure. So it's good to see what the structure is. All the namespaces are also preserved. It's DC colon date rather than DC underscore date that we saw in feedparser. Okay. So task 3, find the first tag, which is CB colon exchange rate. So it's all stored in soup. So I could just type soup.exchange rate and that'll find the first tag exchange rate and everything that's inside that tag. So you can see there's the closing tag for exchange rate. Okay, we look at the solution here. I could also have done soup.find exchange rate, and that's equivalent to soup.exchange rate. It'll find the first exchange rate tag in the soup. And yep, that gives the same answer. Right, so that gives us the tag and everything inside the tag. If we just want what's inside the tag, this text that's inside the tag, we can use .text, which extracts the text from the tag and all its descendants. We can use .string, which extracts the text from the tag only if it is unambiguous, what should be returned. For example, where you'd have ambiguity is where you'd have subtags. If there's exactly one direct subtag which has a string, then it will return that string. Alternatively, you could use .strings. That will extract all the strings, a list of all strings from all descendants. So let's have a look at what text gives us. Okay. It's so a few of them, there's text there, but it's just white space, and then some of the text there is not white space. So that's what we get with text for exchange rate. So task 4, display the string value for a tag which has a string. So we have to find one that's going to be non-ambiguous. So we could do value. And that's CB value. So you notice here we don't do the namespace. It's just assuming that that is unique. And if it's not unique and we do need the namespace, then you would have to use soup.find. And then you could put in the namespace in there. But obviously you can't put colons in a property name of a class object. And we want to find the string value from that, and so there it is, 0.71141. So let's have a look at the solution that was provided here. It goes a bit more detail. So descendants, this finds this descendants here, that finds all the subtags and subtext. Some of the tags have no string, for example, statistics. Text doesn't have a string, but the containing tag of the text does have a string. So we'll make sure there is a tag, and we're making sure it has some string, and then we print the parent of that tag and what its name is. And look at how we're navigating through this soup. You can say we've gone tag is like a subpart of the soup because it's coming through descendants. And we can look at the name of that, just like we said soup.name. We can also say tag.name. We can say tag.parent.name. That'll take us up in the soup, up one parent in the tags. So that's the parent is the containing tag. We find its name and we find its string. So let's run this and see what it looks like. So the tag title is inside item, and it has a string with this value. So it's found a few. Here's the one that we found before in our quick go at the answer. It was 0.7141. And that was value, which is part of observation. And observation was in exchange rate, and exchange rate was in statistics, and statistics was in item. Okay, a couple more examples here. So target currency, we could use text, and that'll give us the text of the first target currency in the soup, which is US dollars, so just USD. And string gives us the same. So there's just some more examples. So you're all being very quiet. I haven't had any questions so far, so I presume you're all understanding how we're going with this. If there's any particular piece of data that you'd like to get out of this RSS feed that you can't see how you would get it, feel free to ask, and we can try to work it out ourselves together. Right, so we've just been using soup dot and then a property name. We could also use soup.find and soup.findAll. So find just returns a single item, find all returns all of the items. So when it returns all of the items, it returns them in a list. So we can put all the items into a list called items and see how many there are. So there's 21 items, so there's 21 different exchange rates that have been provided by the Reserve Bank. So task 5, go through all the exchange rates by currency code and look up the rate for Japanese yen. Thanks, Peter. Yeah. Well, you know, if the currency transactions, if the rate is high for someone, then that means you should be selling, and if it's low, then you should be buying. So, oh yeah, we're going to go through all the exchange rates. So let's do this using list comprehension. So I'm going to create a list, and I want to find the the exchange rate for tag in soup dot find all exchange rate. Now I'm going to extend the list comprehension here. I'm going to put a conditional in here, so it'll just put the items in the list that satisfy a condition, and we're going to want it to be the target currency to be Japanese yen. And how about the string? There we go. And so that's found it. We could put just a string here as well. And 75.37. So in one line, we've answered that task 5. You could look at solution 5. That's a longer way of doing it. We create a dictionary, rates for soup, find all exchange rates. So that's the same as we did up here. We put them in ER. We create the dictionary so that we can look up the target currency. I've used text rather than string here. That also works because there's no subtags. And I store the values in the dictionary, and then we can print all the rates, and we can also find the rate for Japanese yen by looking up that dictionary. So let's run that. So there's the pretty print. The pretty print is sorted by keys. That can be handy in some cases. So before I had to do the sort manually because I was just doing a normal print, but this time I use pretty print, so it's sorted by currency code, and it's given me all the exchange rates, and $1 Australian, 75.37 Japanese yen. I think these exchange rates look a lot better than they did a few months ago, so I'm not too bad, not complaining too much. All right, so at the moment we've been looking at tag names, and we've been looking at the text and string values inside the between the tags, but we can also look at the attributes of a tag. So for example, the channel tag has got the an attribute called about. So let's have a look at the RSS, and we'll go back up to the channel, and so here's the channel tag, and here's an attribute of the channel tag. It's got about, and it's given us the name. It's given us the URL of where this RSS document came from. So we can do this. Soup.channel, find the first channel, there's only one, and tell us the attribute by using this square bracket index code way of doing it, and it gives us the attribute. Now you'll notice that if I just did about, that wouldn't work. You have to use the namespace when you're working with attributes. However, for the tags, the namespace is optional. So we can do rdf:/li, or we can just li, or we can just use this notation .li, and they'll all return the same thing, which is the first li in the soup, and it's all of them are, of course, it's the same thing, so they're a link to the US dollar exchange rate. When you're using find, we don't want to just always find the first one. We might want to find where a particular condition is true. So we can put the condition afterwards like this. So we want the string to be Japanese yen, find the target currency that has a string of Japanese yen, and then we navigate through the soup to find its parent tag to take us up one, and then in there we can find the tag that's value, and then we find text of that. So let's run that. And there we go. So the question was, can we find the list of attributes for here? So I'll create a new cell. So that might do it. .attrs. Let's see if there's any with two two attributes. Let's try RDF. Yep, there you go. So there's the list of all the attributes. Just use .attrs. Thanks, Leo, for that question. Okay, so where were we? All right, so we want to know how to use find and find all. So we can use help. So the parameters to pass, so the first one is name, which is what we've been providing. That's the name of the tag. So just by finding, and the first thing we put in is a tag name, and that'll search on that. We can also provide the attributes. The default for that's an empty dictionary. We can say whether we want to recurse into subtags or just looking at the current level. We can provide text, or we can provide keyword arguments. And there's lots of things you can do with keyword arguments. So, in fact, they also say now you should be using string rather than text for this one, but obviously both will work. When we look at help for find all, it's slightly different because they also provide the limit argument, so we can say how many we want. So if we leave that at none, it will return all of them, but we could just say return the first 5 or the first 10. Okay, so when you do a search, anything in these key value pairs, you can provide a string, a list of strings, a regular expression object, or a callable that takes the string and returns whether or not the string matches for some custom definition of matches. And you can also provide a true. They don't say that there. So I've listed here any keyword argument can be passed string, list of strings, regular expression, function, or true. So let's have a look at some of those, doing each of those examples. Here we've done an example of passing a string against the keyword string. Okay, and let's have a look at a new place to get data from, where it's slightly more complicated. The problem with that XML from the Reserve Bank, it was a bit simple. So let's go to the ACCC, and they've got a website that gives us the petrol price cycles. So if we look at Brisbane, we can see that prices are increasing. Motorists shop around and may find some retailers that have not yet increased their prices. So we want to try to grab that information from the website. So the way to do that, we have to analyze the HTML that's come from this website. So I go to developer view, let's see, more tools, developer tools, and this gives me some information about the structure of the website, and say I want to find out where this information here is. So I click on select an element in the page to inspect it, and then I select it here. I'll make this bigger. Let's do that again. So here we go, it's an unordered list, and that unordered list is it's after an H2, so the H2 is petrol prices in Brisbane. Okay, so let's see what we can do with that. So we put a URL, which is the URL for that website, and using URL open, we pull that into beautiful soup, and this time we're not using XML, we're using html.parser. Okay, so ACCC has now got the soup in it, and what are we trying to do? Find petrol buying advice. Okay, so what are the ways that we could do this? We could find all the H2 tags and see what that gives us. So there's all the H2 tags, because that's what we looked at over here. We saw that it was just after an H2 tag was where the petrol prices in Brisbane was mentioned. There's quite a lot of them. We're only interested in these ones up here that have got a class of TOC header. So we could use find all this way. We could say H2 and then TOC header. And if the second item here is not a named argument, it'll match on class. It's not very well documented, but on the web page for the documentation, it does mention that once. So that's one way of doing it. And so we've narrowed it down to these are the H2 ones, and we're trying to navigate near them. Okay. But one thing that we can look at, we can see that each of these H2s has got an ID. And IDs in HTML are supposed to be unique on the page, so they're actually quite a reliable way to search on an ID and just return exactly the thing that you want. So if the thing you want's got an ID, then chances are you can search on that. So there's two ways of searching on an ID. We can use a keyword argument, ID equals, and that'll search on that attribute. Or we can put it into the attributes argument and provide it as a dictionary. And this form of doing it, the second form, is useful when you're wanting to search on attributes such as name or data-foo that you can't be used in keyword arguments. You can't use that because you can't have a keyword argument with a dash in the name, and you can't use the word name because we've already got an argument called name, which is the first one when we're looking for the tag name, so we can't find an attribute name that way. All right, so this has found the anchor Brisbane. Yeah, so that's the A element. Here we go. That's the anchor. It's got the class and that ID, and so we're pretty much narrowed down into the soup where we want to be. So from there, we want to, from the anchor, we need to navigate up to get to the H2, because the H2 encloses the A. And then we can move through the siblings to the H2, which is everything on the same level. So parents are containing tags, children are subtags, but if you're looking at a tag that's at the same level, then they're called siblings. And we can just keep looking at the next siblings until we find the one that's got the name of UL. So we've got a loop here that'll keep looping until it finds, until it is equal to UL, and then it'll stop. And then we can look at the text in UL, and that'll tell us what the current recommendation in Brisbane is. Okay, so it goes through the loop, looking for UL, found, so the first thing it found was a none tag, which is of type navigable string, and it had a new line in it. Then we found a P tag, which had text in it, and the text was buying tip. Then we found another none tag, and then we found a UL tag, and this one had the text in it. Prices are increasing. If motorists shop around, they may find some retailers. Okay, so we can print out that. So you can see that these siblings include these navigable strings, which are just white space in the XML. So you just have to be careful when you're navigating to be aware that they can come up as siblings. So you couldn't just count how many siblings and think it's the next one. Right, now the previous example was a common requirement, so there's actually a function called find next sibling UL. So we could have done that. We could also have gone upper parent. No, we couldn't have gone upper parent and then find the first UL, because going upper parent would find all the other cities as well. Okay, so now that we know all that, what's a quick way we could have answered that question? Task 6. So we could have said we want to find the ACCC, we want to find the ID equals, and then it was going to be petrol prices in Brisbane. Okay, and that will give us the anchor. So then we want the parent of that to give us the H2. Parent, and then we want to find the next sibling, which will give us that's a UL. And then we want the text from that UL. And how does that go? I think that's going to print it all in one line. That's right. So we want to make that look a little bit better. So we'll put that all in a print statement. And there we go. Prices are increasing and motorists shop around. They may find some retailers that have not yet increased prices. So I recommend you have a go at trying different searches here. Go through the documentation. They've got lots of good examples on that page on crummy.com, who are the people who wrote Beautiful Soup. And see what you can find. Where we said find next sibling, you could probably also have done just find next, and that will probably also work. So let's try that. Yeah, so find next also worked. Okay, find when the next low price is going to be. So if we look at the petrol price cycles here, we're given a table, and it says the first day of the cycle is the low price. So they've got 29th of May, so they haven't updated it yet, when the graph here is showing 25th, 24th of July as the lowest price. So there's that, and they give us how many days they think are going to be in the cycle. I don't know why they're saying 27, but anyway, let's assume they got it right. So what we want to do is we want to take the last low price, we want to add in the number of days in the cycle. So how do we find our way, navigate through the HTML to get to here? So if we look at here, we've got our H2, then a paragraph, then the UL, then another paragraph, information on the past 5 price cycles, and then the table. So table is just a sibling. Inside the table, we've got a head, which is the titles on the table, and the body. The body's got 5 rows, and in the row, we've got 5 cells. Let's have a look what we're trying to do. So find where the next low price is going to be. So we've got Anchor Brisbane, we can use that again. And we just want to find the next table. I don't think I'm going to do it any differently to the solution here, so let's just read through the solution. So we find the next table. from the table we want to find all the TRs, and then we can look at the last row. So TRs is just a list, so -1 as an index tells us the last row of the list, and from that we find all the TDs, and then from that we take the string of the first TD and we parse it and using date time, string parse time. So that's %A is the day of the week, %D is the day of the month, %B is the month name, %Y is the 2-digit year name. We get the days in the cycle, so we look at TDS4, which is the 5th TD in the row, convert that to a string, then convert that to an integer, and we add the previous low to the number of days in the cycle, and we should get our ACCC's prediction of when the next low is going to be. So let's see what they say. 25th of June, so they got that one well wrong. All right, any questions about that? No, I think that was all pretty straightforward. All right, so let's try doing regular expressions. Now, regular expressions are quite complicated. You could spend hours and hours just looking at regular expressions. So we're just going to look at some very simple ones. As a hint, I recommend people look at sites like regex101.com to practice your regular expressions. So if you go to regex.com, you can say here you want to use Python regular expressions. They're just slightly different. You type your regular expression in there and you put your test string in here and it'll tell you what matches that it comes out with. So what do we want to do? We want to find the last low price for every city with a name ending in E. So we've got to come up with a regular expression that finds the cities that end in E. And we might do a search on IDs. So let's try to create a regular expression that will find the cities ending in E. So if I had strings here, say Sydney, I'll do it lowercase, Brisbane, Adelaide, Perth. Okay, so I can just, regular expressions, if you're just matching exact text, I can do that, and it's found 4 matches for me. So it includes all the cities there. Now I want to include the next bit is going to be a word, so it's going to be made up of word letters, and the last letter is going to be E. So in regular expressions, I don't know if they've got down here, you can see any word character is /W. All right, so if I do /W, you can see it now matches the first character of every city. So that's great. But I want several characters to be matched. So let's have a look at my codes down here on the right. If I do an asterisk, that's 0 or more. If I do a plus, that's 1 or more. So I could use either of those. So let's do a plus. Okay, so that matches the whole city name. I've got as many word characters as I can, and I've got 4 matches. So now I want it to end in E. So if I say an E after that, I've got petrol prices in Sydney, and there's an E in there, so it's matched that. But it's if I'm going to match on ID, it's going to have to be an exact match. So this should be fine. Oh, and then but I want it to be at the end of the line. So So let's find out what end of line is, end of line character. So end of string is $sign. So I put a $sign at the end of the character, end of the line, and then it'll only match an E if it's at the end of the line. And then I've narrowed it down to those two matches. So there's my regular expression that I'm going to use. And let's see, find the date of last low price. So I'm not going to do it any differently to this solution, I don't think. So ACCC find all. We get the regular expression here. So /W, I've used asterisk rather than plus. We could have used either in this case. E and then dollars for the end of the line. And I've used a raw string in Python. So there's an R at the front. And you'll notice even on regex101.com they recommended using R strings. And that means that slashes are regular expression slashes. They're not Python slashes. So if you use a backslash like that in a normal Python string, it will be escaping characters. So \n is a new line, \r is a carriage return, \t is a tab, and \/ is how you get a backslash. So if we were trying to build a regular expression using normal Python strings, we'd have all these double backslashes where really we're wanting single backslashes. So by using the R out the front here, we don't have to use double backslashes every time we want a single backslash. So this is good. It looks exactly like it did on regex101.com. So our ID is our keyword. We set it equals to the re.compile because we can use a compiled regular expression, and it will find all the anchors and extract out the cities from that. So how are we doing that? Oh yeah, we're looking for the title of the anchor, and in the title of the anchor we're looking for the space and the last space. So rfind says find the last space, and then we take everything after the last space, which will be the city name. Re is not defined because I didn't run this cell up here. There you go, it's found 3 cities ending in the letter E, and it says when the last low price was, 2nd of June, 29th of May, and 18th of June. Good. So Jean says he's enjoying the tutorial, so great. Hope everyone else is too. All right, task 9. From the RBA website, find the full name of currencies of IDR and INR. All right, so we want to, in this case, we want to search from the website rather than the RSS feed. So let's have a look. This was the RSS feed, but remember that came from a website. And in the website, they give us the full names of the countries that have got the of the currencies rather than just the codes. So let's have a look at a developer look at this. And we'll inspect one line in this table. And we see the ID of the row is the currency code, and the first cell, which they've used a TH cell, is going to be the name of the currency, so Singapore dollar. Okay, so we want to find IDR and INR, and we want to find out what the full codes are for those ones. So how do we do this? First of all, we have to create a soup. So we get we store the URL into the in our variable URL. we'll create a soup for this, and let's see, soup. We'll open the URL. This time it's HTML, not XML. So we use the HTML parser, and there's different HTML parsers you can use. You can actually use LXML library for HTML parsing, but on the documentation they give you the different pros and cons of each one. So we'll store the soup into RBA HTML, and then we want to find all the rows that have got an ID that's either IDR or INR. And so this is going to be an example of using a list of strings when we're doing a find. And we can just use a keyword argument, so we could have done any keyword, and the IDs are going to be IDR and INR. Okay, so that should give us the rows, and then we want to find all the heading cells in those rows. So we can just say find all. Oh, well, that's a list actually. So I've got to store that in a list. So we'll call them the TRs. And then we'll just find the names of those. So let's use, I use dictionary comprehension this time. TR in TRS. So the TR is going to have a TH, and the TH is going to have an ID. Okay, and that's going to be the key in our dictionary, and the value is going to be the text of the TH. I think it's actually just the TR's ID. Okay, so there's a solution. It says IDR is the Indonesian rupiah and INR is the Indian rupee. And the solution 9 down below is just gone a bit more, formatting the answer a bit more nicely. So look how that does it. Yep. Okay, so how are we going through examples? Task 10. All right, so we want to look at the RBA page again and look at the rates over the last 3 days. Find the currencies where the rate has both increased and decreased over that time period. So this is an example of where we're going to use a callable for finding. So at two options, we could have just read in all the rates and then run a Python program that went through and checked whether the rates have gone up and down or down and up. But in this case, we're looking for an example of how to use a callable in a soup find all command. So I've created this function here. I think we'll just go straight through the solution they provided rather than try to create it again from scratch. So I've called it procrastinate. So it's a rate that's procrastinating. It doesn't know whether it's up or down. And so it gets a tag, and the tag is going to be a TR. If it's not a TR, I just return false. If it is a TR, I look at the TDs that are in it and convert them to floating point numbers. And at that point, I see if we've either got a case of R1's gone up to R2 and then down to R3, or R1's gone down to R2 and then back up to R3. So if that's true, otherwise it'll be false, in which case it's always increasing, always decreasing, or two of them at the rates are the same, two or more. Okay, so when I do the find, I'm finding H2 tags. I've got to find where I'm starting from, so I'll find the H2 tag for latest exchange rate. So let's have a look and see how we're going to get there. So there's the H2 tag that says latest exchange rates, and then I want to find the table that's after that, and then I want to find all the rows and check all the TDs on each row. So the H2, where the name is latest exchange rates, then find the next table, and just look at the body. So we can ignore the heading, because the heading has got the column title, so we don't want to be testing for that. And then in the body we find all the procrastinating rates. So yep, I've been through all that. I don't think there's anything more to explain in this. Oh, and then I find the TDs in that for printing out the results. So let's see what it comes up with. So the procrastinating rates, the Japanese yen, we can see that's gone from 75.41 down to 75.3 and then back up to 75.37. The New Zealand dollar has gone down and then way back up. The Indonesian rupiah has gone up and then down. New Taiwan dollar has gone up and then down. So yes, we've got about 6 of them have been procrastinating. All right, so they were all the difficult ones. Now I'll find a task 11. It's the last task on the list. There's a much easier one. Let's just find all the tags that that have an ID. So once again, we're looking at the RBA website, and let's find all the. We can just say ID equals true, and this is the last example of a different way to putting in a search term. So when we put in search for true, it means it has to have an ID. So we're just trying to find all the tags that have an ID. So let's run that. That was pretty simple. And here are all the tags that have IDs. So you can see there the rows of the table that we were just looking at, they had IDs. We've got a div, a form, etc. Now one thing that's interesting is the H2s are not in that list. And yet when we looked at the H2 here, we got H2 ID equals latest exchange rates. Now that had me confused when I first did this. I go, why is the H2 not showing up in the list of tags that have got IDs? Because it's clearly got an ID. So then when I did, I thought, well, show me all the H2s in rba.html. I'll find, I just do, find all H2s. And there's the H2s. So they exist, including the one latest exchange rates, but none of them have got IDs. So what's happened here, the way the Reserve Bank has generated their website, is they've created the website and then they've had some JavaScript go through afterwards and put in these IDs. So that's a little bit of a limitation with Beautiful Soup, as it's just looking at the HTML that comes when the site first loads, not after the JavaScript has gone through and made changes to it. So if you need to do that, then you need to start. It's a much more advanced topic. You're looking at using things like Selenium, which use Chrome engines that can load the website, run the JavaScript and then return the HTML after the JavaScript is run for you to then start searching on the information out of it. But that's beyond the scope of what we're going to do tonight. But I thought I'd explain it to you so that if you come across that information, that scenario, then you're not lost. Okay, so that's all for tonight. Are there any questions for that? Why does the website need to add the ID later? That's right. It'll probably be because of something else that the JavaScript does. I'm not sure. I couldn't see anything that it needed the IDs. IDs are, it could be possibly for styling, but it would be very unusual to not just put the ID in the original HTML if you needed it for styling. I'm thinking they've got something on that website that is running in JavaScript for some reason. They find it easier if those H2s have got IDs. So did you find the stuff that we went through useful today? Oh, Helena wants the updated notebook. I don't know that you need the updated notebook because everything, I haven't added much. The solutions that I provided are more comprehensive in the original notebook than what I've provided. But I'll make a copy of it and provide that. Okay, I'll do that now. So let's. Anyone with the link? I'll try putting the link into here. I mean, as a different user. All right, let's try that. I'll put it on the Slack for now. And yeah, and I'll put this in the comments on the video afterwards when I stop the video. So is there any more questions? Okay, thanks for joining us. Next week is first week of the month, so it'll be an absolute beginner session. We'll just be looking at an introduction to coding and program flow, writing functions, just very basic stuff. It can be helpful if you've done Getting Started 1 and 2, but you don't need to. Any question is fair game. So I'll try to go over the stuff that you need to know as though you're an absolute first timer. So please come next week if you want to get a real introduction to Python. And the following 2 weeks after that, Arun will be doing some machine learning stuff. So come back for Arun sessions if you're interested in machine learning. So thank you very much for your time.